Okay, for this review, I'm probably only going to be able to do one problem in each section. So for 6A, first problem there, number 1, use the calculator. It's plugged it in. We have to find vertical and horizontal asymptotes. We find the vertical asymptotes. So I have it in the calculator. Look for my errors. We have 1 and -3. 1 and -3. You then have to look back at the graph. 1 and -3 for our vertical asymptotes. And at 1 I can clearly see a vertical asymptote. I'm going to zoom in on -3 to see it a little better. And there's a vertical asymptote there also. So I have 2 vertical asymptotes, one at x equals 1 and one at x equals -3. These are vertical asymptotes. Horizontal asymptotes come from the equation. I have biggest exponent of the variable in the numerator is 2 and in the denominator is 2. When this happens, we have the exact same powers. Biggest powers are the same. You use the coefficients. So the horizontal asymptote in this case is y equals, vertical is x equals, horizontal is y equals -1/4. Moving on. We have, now the only thing different, we have to identify points of discontinuity and the holes. So we're going to put this number 3 into the calculator. Okay, I lied. I'm putting number 4 in because it's a little different. Go to graph it. Clearly see that I need to hit zoom 6. You see, not a whole lot, but let's go to the table. Error at 0 and 3. So 0 and 3, look back at the graph. At 0, at 3 I can see a vertical asymptote at 0. Not really sure, so let's zoom in. And I can see a vertical asymptote at 0 and 3. So x equals 0 and x equals 3 both have asymptotes. So I'm going to put a dashed line now that we have to draw these graphs at 0 and at 3. Horizontal asymptote comes from the biggest exponent of the numerator of the variable. There isn't a variable, so we just write in x is 0. And then 2 is the denominator's biggest exponent. 0 is less than 2, so then always, always, always the horizontal. When the numerator's exponent is smaller than the denominator, it's always y equals 0. And you can see this on the graph too. Y equals 0. Right along the x-axis. Now, points of discontinuity. Points of discontinuity are all of your errors. So when I looked at the errors, I skipped over this, but those are the points of discontinuity. X equals 0 and x equals 3. Sometimes those are also, when we look back at the graph, those can be holes, but in this case they're all asymptotes, vertical asymptotes. Now we have to just draw this graph. I'm going to go to the table, see if I can find any points, nice points to graph. I'm seeing all decimals, so that's not going to help me. So I just look back at the graph and make sure I don't cross over any x or any asymptotes. So I see this comes here, a little u in here, and the second part's over here. Alright, moving on. I'm going to do number 6. I'm going to graph this. Get my zeros. Left. Down below in this case, right above. And 2.6 repeating. So 2.6. You guys ask me how many 6s? A lot. I don't know. At least 1.5 lines worth. Math. Frac. 8/3. So this numerator is 3x minus 8 as a factor. Back to the graph. I think I'll be able to find the other one here. There it is at -2. So that's x plus 2. Now, I think we did forget something right away. Probably forgot the greatest common factor. Greatest common factor between 9, 6, and 48 is 3. So I have to put that up front. In the denominator, the greatest common factor I can see is 15. I probably should put in 15x squared minus 15 to make sure, because there's a square left, make sure that see if I can factor it further. So go to the graph. I got -1 and 1. So it does factor further. So x plus 1, x minus 1. We'll then look to simplify. Not a whole lot. Numerator and denominator are the same. I have 3/15, which reduces to 1/5. And that would be my answer. 3x minus 8, x plus 2 over 5 times x plus 1. The back of the packet might have a different answer. It might have actually multiplied out the numerator or denominator or both, but there's really no need for that unless the answer choices tell you you have to. Moving on, we're going to do number 8. With number 8, we have to get like denominators because we are subtracting. Only when adding and subtracting, you need to get like denominators. So 30r plus 36 over 30r plus 36. First fraction r minus 3 over r minus 3. So we're going to have to get some more room here. So breaking this down, we have 4 times r minus 3 minus 3 times 30r plus 36. That's all over r minus 3, 30r plus 36. Same denominator. Oh, you guys skip this step. Go straight to the next step. Multiply this in. R minus 12. Multiply this -3r in. Minus 90r squared. Not plus, minus 108r. That's all over r minus 3 times 30r plus 36. Gather like terms, rewrite this biggest exponent to the smallest in the numerator. Got -90r squared. Like terms, negative 104r, and let's subtract 12. Now once you gather like terms up in the numerator, we have to factor the numerator, or try to factor it at least. You can see they're all even, so there's going to be a greatest common factor, but I'm going to put this in the calculator first. Alright, I checked in the calculator. Those decimals are not factorable. So we're just going to take the greatest common factor out of the numerator, which is 2. So if you take a 2 out, you get -45r to the 5th squared minus 52r minus 6 over, can't factor anything out, r minus 3, but 30r and a 36, I can take the greatest common factor out of that. And that would be 2, 4, 2. So times 2, 15r plus 18. Numerator and denominator, I can cancel out those. And what's left is my answer. -45r squared minus 52r minus 6 over r minus 3 times 15r plus 18. That would be it. Moving on. Okay, the last packet I solved a lot of problems like number 11, so I'm going to solve a problem like number 12. I see in this numerator here two fractions I have to subtract. What I have to do is multiply to get like denominators, so 4 over 4, m over m, get like denominators. We write this 9m over 4m minus 4 over 4m. That's still all over 2m. Combine those numerators, 9m minus 4 over 4m divided by 2m. And we're going to keep it, change and flip it, but we need a fraction over another fraction, so put 2m over 1. So rewriting this, write it down here. We have, I guess I gotta see it, write it. 9m minus 4 over 4m times 1 over 2m. If you go to factor each numerator and denominator, nothing to factor, nothing to simplify. So just multiply straight across. 9m minus 4 times 1 is 9m minus 4. 4m times 2m is 8m squared. So there's nothing to simplify, and that will be your final answer. Okay, last problem. We will do number 14. So these problems, the first thing you have to do, factor the denominator. So you should always do GCF first. Sometimes you forget to, but you got to go back. Greatest common factor of the first term's denominator is 2. And then we got to use calculator. Alright, so I put in the calculator the denominator, 6x squared plus 20x plus 6. I get negative 1/3, which is negative, or negative 0.333, which is negative 1/3, which is 3x plus 1 is a factor. The other one is negative 3, which is x plus 3. I guess those should be b's. Okay, so change that. So it's 3v plus 1 and v plus 3. So our last denominator is the same thing. So we have to look what's in all of our denominators, this last one. Is this also? The middle denominator is not the same as all the other ones. So I have to multiply by, right now it has v plus 3. I also have to multiply in 2 over 2. And I have to multiply in 3v plus 1 over 3v plus 1. So I'm going to rewrite this because this is pretty sloppy, but if I multiply by a 2 and a 3v plus 1 on the middle term, that'll give my like denominators, and then our numerators will become 4 times 2 times 3v plus 1 equals 3. Now 4 times 2 is 8. 8, multiply that in. 8 plus 1 is 9. Subtract 9 from our room. 24v equals negative 6. Divide by 24. Simplify that. Reduce it to negative 1/4. If you guys have any further questions, you're more than welcome to come before school on Monday. I'm here at 6:30, 6:45. Monday after school if you're taking tests on Tuesday. Otherwise, good luck and study hard. Thanks.